For the second setup, to machine the backside of the sprocket, we're going to use this fixture. And I provided this fixture model for you. And we're going to place the sprocket on the fixture. You can see it has these protrusions that fit into the spokes of the sprocket to clock it appropriately. And I've included a screw because basically the stock material is going to be held down onto the fixture with the screws coming up from the bottom. And so the first thing I'm going to do is just constrain everything together. So I'm going to ground the fixture so it's not moving. I'm going to make this face here mated to the face of the flat face of the sprocket, because our stock material, we've faced that, and that is the flat side that is going to be down so that we can machine the back side of the sprocket. So I'm going to hit apply there. And then I'm just going to basically make these holes here aligned. So I'm using a mate constraint on the axes of a couple of the holes. And so now we have the sprocket sitting down on the fixture. And I'm just going to place in one of these screws. When we assemble it, you're going to put all 6 screws in to make sure that the sprocket is held securely to the fixture. But the reason why I'm putting one in is I just want to make sure that the screw doesn't stick up too far. So it looks like a 1-inch button head screw is just the right length to hold the material down without getting hit by the tools as we machine this slope face. So now that we have this, we need to set up the stock and the work coordinate system. Now, if you recall from setup 1, our stock was 4 inches square and a 1/2 inch thick. However, in setup 1, and I'll bring that up, we faced off this material here. We centered the stock, or centered the model in the stock, and then we faced off this material. So the remaining stock is not a 1/2 inch thick. We have to subtract off this thickness. And so to figure that out, let's measure the thickness of the sprocket. So the thickness of the sprocket is 0.447, and the thickness of the original stock was 0.5. So basically, let's go to a calculator here. We have 0.5 inches minus 0.447, and half of that was machined off. So we can see that that's a little over 26 thousandths, 26.0265 inches. And so our remaining stock is a 1/2 inch minus that number. So our stock thickness now is 0.4735. So going back to the assembly, I gotta make sure I'm on the right one. Okay, on the setup, so we'll go to CAM, go to setup. First thing I wanted to do before I deal with the stock is tell Inventor what the model is. And I need to do this whenever I have an assembly. We never have to do this when we're just machining a single part, but when you have an assembly, Inventor just automatically assumes you're machining everything, and we're not machining everything, we're only machining the model. So I need to define the model and the fixture. So that's the model, that's the fixture. The screw is actually part of the fixture as well. So we have that. Next thing I'm going to do is set up the work coordinate system, and then we'll go to the stock. As I mentioned in the assignment, the origin is going to be at the top surface of the fixture, not the stock material, because the fixture is a well-defined position. The stock material, we have maybe varying thicknesses and things like this, and we want the sprocket, we've already machined one side of the sprocket, so we need the other side machined properly relative to the first side. And so we're going to be zeroing off the top of the stock, I'm sorry, at the top of the fixture, but we're going to use the sprocket, and we're going to do a bore. We're going to use on the probe, we're going to use a setting to find the center of that bore. And so we need to get the origin down here. So I'm just going to go select a point, and I'm just going to click on that point. I made a sketch on the fixture so it's easy to select. And you can see that the x-axis is going through two of the holes which we had on the first setup, and we have the z-axis pointing vertically upward, and the origin is at the top of the fixture. You can see here's the top of the fixture, and the origin is at that point. So there we go with the work coordinate system. Now we need to go to the stock. We're going to do a fixed size box. We know that it is 4 inches wide, 4 inches deep, and it's 0.4375 high. Now, the model is not centered in the Z anymore. The model is at the bottom of the stock, and so what we need to do is make sure that the model position is offset from negative Z, and then we're going to have no offset at all. And so that's what we have. Now it looks like I have the wrong height because I must have typed in the wrong number. Let me go back to the calculator. It's 4735, not 4375. And so going here, 4735, you can now see that the stock material rests above the actual model, but the bottom of the stock material is right at the bottom of the model, which is what we have in real life. Now, this is not a realistic stock because if you remember, we machined down to about this height right here, and so this material is gone. We could design or create a more realistic stock material, but it really isn't necessary. So I'm just going to leave this like this and hit OK. So now we have the setup complete, and we can move forward with the different operations.